NASA shuts down quantum computer after a shocking incident. In a world that is progressively moving towards embracing revolutionary technologies, the quest for quantum computing has been at the forefront of numerous research endeavors. NASA, one of the leading institutions pushing the boundaries of scientific discovery, has long been involved in experimenting with quantum computers to solve some of the most complex problems in science and space exploration. However, a recent shocking event at NASA's quantum computing lab has led to the abrupt shutdown of their advanced quantum computing system, raising questions about the risks and limitations of this cutting-edge technology. The rise of quantum computing at NASA. Quantum computers, unlike classical computers that rely on binary systems, ones and zeros, use quantum bits, or qubits, to process vast amounts of information at an exponentially faster rate. Qubits leverage the principles of superposition and entanglement, which allow them to exist in multiple states simultaneously and interact with each other in a profoundly complex way. This opens up the possibility of solving calculations that classical computers would take centuries, if not longer, to complete. NASA has been investing in quantum computing as a potential game-changer in space exploration. The space agency's missions require processing immense datasets from deep space probes, simulating orbital mechanics, solving optimization problems in spacecraft routing, and understanding complex phenomena like gravitational waves. By incorporating quantum computing, NASA aims to tackle these monumental challenges with unprecedented speed and efficiency. In collaboration with Google and other leading tech firms, NASA has been working on the D-Wave quantum computer since 2013. This partnership aimed to push the boundaries of quantum computing in real-world applications. NASA also sought to understand quantum computing's implications for artificial intelligence and machine learning, intending to employ the technology in future missions to Mars and beyond. The quantum leap, a promising future or a dangerous frontier. The promise of quantum computing was not without concerns. Skeptics had warned that the complexity of quantum systems made them highly unstable. Even slight disturbances in the environment, like temperature changes or electromagnetic interference, could cause quantum computers to lose coherence, rendering calculations useless. Yet, these challenges were often seen as temporary hurdles that researchers would overcome with improved algorithms, hardware, and error correction techniques. At NASA, the quantum computer had demonstrated tremendous potential. It had shown remarkable results in optimization problems, and the researchers believed they were on the verge of a breakthrough that could redefine computational limits. The excitement was palpable. A new age of quantum supremacy, where quantum computers outperform classical ones in specific tasks, was within reach. The incident. What happened? The shocking incident that led to NASA's quantum computer shutdown occurred during a routine experiment. Although details of the event remain classified, reliable sources within NASA have hinted at an unexpected anomaly during the quantum system's operation. What initially appeared to be a minor glitch rapidly escalated into a much larger issue, affecting not only the quantum computer but also the lab's entire computational infrastructure. According to reports, the quantum computer began generating anomalous results during an optimization problem related to space mission trajectory planning. Instead of providing the expected outcome, the quantum machine's calculations deviated in a bizarre manner, yielding data that was entirely inconsistent with the input parameters. The magnitude of the error far exceeded anything the team had previously encountered. Attempts to reboot the system proved futile. The computer, which operates in a cryogenic environment to maintain qubit coherence, began exhibiting erratic behavior, leading to concerns about a potential hardware malfunction. Yet, as the engineers and quantum scientists scrambled to investigate the issue, something even stranger occurred. The chain reaction, beyond a simple glitch. What happened next has been described as a cascade failure. The quantum computer, connected to a larger network of classical computers that assisted in data analysis and system monitoring, began to disrupt the entire network. Servers that were initially independent of the quantum system started experiencing unexpected crashes, corrupting datasets from other ongoing missions. Initially, we thought it was an isolated incident, said a NASA insider familiar with the situation. But within minutes, we were witnessing errors across multiple systems. It was as if the quantum computer had triggered a domino effect that we couldn't stop. While quantum computing relies on unique hardware, The underlying algorithms and systems are often connected to conventional supercomputers for broader calculations and error corrections. The exact nature of the anomaly remains unclear, but one theory suggests that the quantum computer may have entered a state of quantum instability, sending disruptive signals across the network in ways that even experts couldn't fully comprehend. The decision to shut down. Faced with the escalating situation, NASA made the unprecedented decision to completely shut down the quantum computer and its surrounding systems. This decision wasn't made lightly. The agency had invested years of research and millions of dollars into developing and maintaining the machine. There was no other choice, a senior NASA official stated in a debriefing. The risks outweighed the potential rewards. We needed to assess the situation carefully before causing further damage, especially to critical missions that rely on our computational resources. As NASA began conducting an in-depth investigation, the team focused on potential causes for the malfunction. Could it have been an error in the programming? Was there a previously undetected hardware flaw? Or could external factors, such as environmental interference, have played a role? The speculative theories. Could it be more than a malfunction? Although NASA has been tight-lipped about the specifics of the incident, the scientific community has been abuzz with theories. Some speculate that the quantum computer may have unintentionally tapped into a quantum phenomenon that researchers are not yet equipped to understand. In quantum mechanics, particles can interact in unpredictable ways, leading to outcomes that defy classical logic. One particularly interesting theory is that the quantum computer, in processing such a massive volume of data, may have entered a state of quantum entanglement with external systems, causing interference across multiple networks. While this idea remains highly speculative, it does raise the possibility that quantum computing's inherent unpredictability might be its greatest challenge moving forward. Other theories suggest that the quantum system might have encountered a quantum leak, a hypothetical scenario in which information from parallel quantum states spills into our classical reality, creating unintended consequences. Though this concept is largely relegated to the realm of science fiction, some scientists argue that as quantum computers become more advanced, the line between theoretical possibility and practical application may blur. NASA's response: a pause or an end? In the wake of the shutdown, NASA is conducting a comprehensive review of its quantum computing operations. The agency has brought in experts from around the world to help diagnose the issue and determine whether the quantum computer can be safely restarted, or if it will need to be decommissioned permanently. We are committed to understanding exactly what happened and ensuring it doesn't occur again, said a NASA spokesperson. Quantum computing holds immense promise for our missions, but safety and reliability must come first. We will not proceed until we are confident that our systems are stable. As of now, NASA has not announced any plans to restart the quantum computer. The research team is exploring the possibility of developing new error correction algorithms and more robust hardware to prevent a recurrence of the anomaly. However, some insiders believe that NASA may move away from quantum computing altogether, focusing instead on advanced classical systems until the technology matures. The larger implications for quantum computing. NASA's experience raises important questions about the future of quantum computing. While the technology offers groundbreaking possibilities, it also carries significant risks. Quantum computers operate in a realm of physics that is not yet fully understood, and their behavior can be unpredictable. If a malfunction in a quantum system can disrupt an entire network of classical computers, the potential for widespread damage in other industries is concerning. Quantum computing's applications extend far beyond space exploration. Fields such as cryptography, pharmaceuticals, climate modeling, and artificial intelligence are all exploring quantum solutions to solve complex problems. However, NASA's shutdown incident serves as a reminder that the technology is still in its infancy, and its risks must be carefully managed. The road ahead: cautious optimism or a step back. Despite the incident, many researchers remain optimistic about the future of quantum computing. They argue that such challenges are a natural part of the development process for any revolutionary technology. The same concerns were raised during the early days of classical computing, when crashes and hardware failures were common. What we're seeing is not necessarily a failure of quantum computing, but a learning curve, says Dr. Samantha Harris, a quantum computing expert at MIT. NASA's experience will provide valuable insights that will help us build more resilient systems in the future. As NASA continues its investigation, the broader scientific community will be watching closely. The space agency's experience could shape the direction of quantum computing research for years to come, influencing how companies, universities, and governments approach the development and deployment of these powerful machines. For now, the future of quantum computing at NASA remains uncertain. Will they restart their quantum system after addressing the issues, or will they retreat to the safety of classical supercomputers? Whatever the outcome, one thing is clear. The road to quantum supremacy will not be without its challenges, and the journey is only just beginning.